Hello everyone, welcome back to my organic chemistry mini lecture. Today I will pick up a big topic that is the nomenclature. And today I cannot cover everything, so just give you the basic rule and then we'll talk about the name of acyclic compound. Based on IUPAC, first, for organic compound, we need to find the longest continuous carbon chain with the most substituents. And that is the parent hydrocarbon, or sometimes just the parent alkanes. And based on the number of carbons, we will have different prefix. So I will tell you more about that in next slides. Okay. So now second rule, you have to number the chain in the direction that give the substituents as low a number as possible. Okay. If you have ties, you have to look at the further substituents until you break the tie. And third, you need to give the lowest number to the functional group with the highest priority. Okay, the different functional group, they have different priority. Here, I give you a simplified priority order because this not cover everything. I just give you some very typical functional group, the highest carboxylic acid, and then aldehyde. Of course, there are other functional group between these two, but that's the most common functional group, aldehyde, and then ketone. That's the order from a high to low priority, ketone, and then alcohol and amine, and unsaturated compound like alkene, alkyne, and then alkyl group, halo group, that's halogens, and alkoxy group. These groups are lowest and they have the same priority. Now you may notice I have a suffix and a prefix, and that is when you have this functional group is the highest of priority in the compound, you will call this compound and put this name to the suffix. And for example, if you have aldehyde as the highest priority in the compound, and you call this compound as aldehyde, so the suffix will be Al, means aldehyde, Al. If the aldehyde is not the highest priority function group, then you will give this prefix oxo. Okay, you treat this as a substitution. So that's the two different name. Depends on the situation. So I will give you more examples later. Okay. Number 4, we will use alphabetic order to break a tie if nothing else can do so. Okay. So I'll give you examples also. Last, you always put the different substituents in alphabetic order in the final name. Okay, always. Now, before we give the examples, we will talk about the common substituents and the prefix, like I just said, okay, for the organic compound. First, it's common alkyl group. This is the common, not all of them, okay. So if just a one carbon alkyl group, that's called a methyl group, okay. So this sign means it's incomplete bond. You need a bond with something else. This is substituents, okay. Or skeletal structure like that. That's just, when you see that, just one line sign kind of, that's methyl group. Ethyl, 2 carbons, alkyl group, okay, or skeletal structure, ethyl. Propyl, that is normal propyl, okay, and that's a skeletal structure. Isopropyl is the isomer or a different connection, okay, you still have 3 carbons, but that's isopropyl. You can see this isopropyl, the connection is from this secondary carbon here, and or skeletal structure, isopropyl. Butyl, there are 4 different butyl. This is normal butyl, just linear without branches, and that's a skeletal structure here. Isobutyl, you have a isopropyl group, but with 1 more carbon, so that's isobutyl. Secondary butyl, and that connection is from the secondary carbon of this butyl group. And terbutyl, that means this connection from the tertiary carbon here. So that's the different connection. So that's just a very normal, common alkyl group. Now let's talk about the alkoxy group. Alkoxy is similar with alkyl, but with one more oxygen here. So this is methoxy, skeletal structure. This is ethoxy. That's a skeletal structure. That's isopropoxy, and that's a skeletal structure. And that's a butoxy, and that is the skeletal structure. This is useful when we talk about the name of ether later. Okay. Then this is aromatic group. This is the phenyl group. Basically, is the when a benzene loses one hydrogen, so that's the group. Okay. This basically is benzene, but without a hydrogen, or just pH. That's the just the symbol. Benzyl group, just a phenyl group with one more carbon. That's methylene group here. Okay, that is also have the symbol as Bn, benzyl group. And then vinyl group is just a double bond here. Okay, so it's vinyl. And allylic group, just one more carbon than vinyl group. Okay, that's also common. It's not aromatic here. Okay, so I just put in the same category with this two aromatic group here. And the last one is halogen. Okay, halogens, fluoro, chloro, bromo, iodo. Okay, that's the simplest one. Then we'll talk about prefix based on the number of carbon in the parent hydrocarbons. If it's just one carbon, meth. 2 carbon, eth. 3 carbon, prop. 4 carbon, bute. 5 carbon, pent. 6 carbon, hex. 7 carbon, hept. 8 carbon, oct. 9 carbon, non. 10 carbon, dec. Okay, that's the normal. Of course, you could have more carbons, then the prefix will be more. But I just give you the most common prefix. Now, based on all this information, we can give you some examples. First, alkanes. Okay, alkanes, only hydrogen and carbon in the molecule. I'll give you 3 examples, and I also copy paste the priority order here for just for convenience. When we have alkanes, then that's the lowest priority. We don't have any higher priority. That's alkane. And the first rule, you need to find the longest carbon chain. Okay, continuous carbon chain. We will number this carbon as 1, 1, 2, 3, 4, 5, 6. Okay, so you don't want to number this is 1 because if you now 1, 2, 3, 4, 5, that's shorter. If you go to 1, 2, 3, 4, 5, 6, that's also 6. But this substitution will have a higher number. This is 1. This will be number 3, 2, 3, 4, 5, 6. So that's the correct number. Now the name will be 3-methyl-hexane. Hex is a prefix because you have 6 carbon in the longest carbon chain. Second example, we will number this as carbon 1. 1, 2, 3, 4, 5, 6. Now you may wondering why don't number this as 1? 1, 2, 3, 4, 5, 6. That's the same number of carbons. However, if you number this one, then that's 2, 3, 4, 5, 6. You will have 1, 2, 3 substitution. If you number this as 1, then you will have just the 1, 2 substitution. So you want the most substituents. So that's why from here. Now you also may wondering why don't number this as 1. And that is because if you number this is 1, then 1, this will be 2. That's 1, that's 2. So yeah, that's a tie. You have a first substituents on a carbon 2. But if you go further, this ethyl group will break the tie because you number this as 1, this ethyl will be carbon 3. If you number this 1, this ethyl will be number 4. So you want a low number. That's why the name will be 3-ethyl-2,5-dimethylhexane. Ethyl and methyl, alphabetical order, we need to put ethyl first, 3-ethyl. And then you have 2 methyl group here. So you have say 2, 5 and dimethyl. Di means the number of the same substituents. You have 2 methyl group, di. Okay. Hex is the prefix of the longest parent alkane. Okay. Last example. We will need first to find the longest continuous carbon chain number, and this number of carbon is 1. Why don't number this carbon as 1? Because from here you will see the 2 methyl group at the carbon 2. If you number this one, you will only see 1 methyl group on the carbon 2. So that's number 1. You have 2 methyl at the carbon 2. And you don't want to number this as 1 because that will be shorter. So from this number 1, that will be 2, 3, 4, 5, 6, 7. If you number this as 1, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, that's shorter. Okay. So now we have to put ethyl also first, alphabetical order, always. Okay. 4 ethyl, and then 2, 2, 6, 2, 2, 6, trimethyl. You have a 3 methyl group. Heptane. Hept is the prefix of the parent. Okay, that's the example of alkanes. Now let's look at the alkyl halides. That means you have halogens substitution. Now first is a very simple example. We have a bromo group on carbon 2. So apparently this carbon should be 1, then 2, 3, 4. Okay. So then bromo will be lowest number. So that will be 2 bromo butane. You don't want to number this is 1 because that bromo will be 3. So 1 to 2. And this carbon is actually an asymmetric center. Okay. Now this we have another example. We have a methyl group and a chloro group. Seems like there's a tie here because if you number this carbon as 1, this methyl will be on carbon 2. If you number this as 1, the chloro will be number 2. So that's a tie. You don't have a third substituent to break the tie. So now you have to use alphabetical order to break the tie. Methyl start with M. Chloro start with C. So you number this as 1, 2, 3, 4, 5. So that will be 2 bromo, 4 methyl, pentane. Pent, again, is a prefix. This is actually important compound here. It's the replacement of the fleon. Okay, so the refrigerant. And this is the 2 carbons compound. We number this carbon as 1, this now carbon as 2. Why? Because on the carbon 1, you will have a 3 fluoro group on carbon 1. If you number this one, just the 1 fluorocarbon. That's why it's 1, 1, 1, 2 tetrafluoroethane. Ethane is the parent. You have a 4 fluoro substituents. Okay, so you have to use comma to separate 1, 1, 1, 2. Tetra means 4 fluoroethane. Now, how to name ethers? Ether, it's a functional group as carbon, oxygen, carbon. Always carbon, oxygen, carbon. Carbon, oxygen, carbon, that's the ether. And how to name the ether? You will, for example, here, you will just treat one of the longest carbon chain as a parent. Then the other part will be the substituents. But for this one, it's a simple one. Okay, so we just say ethoxyethane. Ethoxyethane. Okay, so ethane is the parent. You can pick up this as ethane or ethane. It's the same, 2 carbons. Okay, a common name is called diethyl ether. Okay, but officially we have to say ethoxyethane. We don't have to say ethoxy 1-ethane because this one, that's 2. If you connect, say this one, that's also 2. So it's same. You will not have a different name. So you don't have to say 1-ethane. This example, we have longest chain here. That's just 1 carbon. That's 4 carbons. So we number this carbon as 1, 2, 3, 4. And then this is a methoxy group. So that's 2-methoxybutane. And last example, we have an iodo group here, and we have a methoxy group here. And this carbon should be 1 because then this will be lowest number. Okay, so halogens and alkoxy have the same priority, so you have to give the low number to this aldyl. 1, 2, 3, 4, 5. Then 2 aldyl, 3 methoxypentane. That's alphabetic order, I and M. Okay, that's 3 examples of ethers. Now let's look at the unsaturated compound. I just give the 3 examples that with double bond and triple bond at the same time. Okay, so I will give you another mini lecture, just talk about the name of alkenes because that's more complicated. Now, first one. The first one, we have a double bond here, triple bond here. The triple bond is between carbon 1 and 2, if you number this one. Double bond between 2 and 3, if you number this 1. So we will number this as 1, 2, 3, 4, 5, 6, 7. And the name will be E, hept, 5 in, 1 ine. E, that means the alkene. This double bond is a trans alkene. Okay. Again, I will talk about that more in another mini lecture. Hept is a prefix. We have a 7 carbon in the longest carbon chain. And 5 is the location of this double bond. It's between 5 and 6. We pick up the low number, the 5 in, and a 1 ine, 1 ine. So whenever you have a double bond, triple bond in the same compound, we call this alkyne. Okay, but the 2 functional group, double bond, triple bond, basically have the same priority, but we always call this alkyne. Okay. Second example, we will number this as 1 because it will give the double bond the lowest, okay, number. If you number this one, the alkyne will be number 2. So 2, 3, 4, 5, 6, 7, 8. We have oct. Okay, and then name will be oct. 1 in. It's 1 double bond. Okay, double bond is location is 1, and then alkyne triple bond is location is 6. Okay, so oct, 1 in and 6 ine. The last example, we have a tie, double bond, triple bond. They all are the terminal, so you can number this one or this is 1. So how to break the tie? You have to first give the low number to the alkene. Okay, the chloro cannot break the tie because double bond, triple bond, they have a higher priority than the halogen. Okay, so we just number this one, give the low number to the alkene if there's a tie. Okay, now 2, 3, 4, 5, 6. So that's hex, right? The substitution of chloro is on carbon 4, 4 chloro, and then hex is a prefix, and 1 in and 5 ine. Okay, now let's look at the amines. Amine is the derivatives of ammonia, NH3. When 1 hydrogen replaced by the R group, then that's a primary amine. If there are 2 hydrogen replaced by 2 R group, that's secondary amine. If 3 hydrogen, they're all replaced by R group, that is the tertiary amine. So I'll give you 3 examples. This is the primary amine, and we need to find the longest chain. Number is carbon 1, 2, 3, 4, 5. Why don't number this as 1? Because you still give the number 3 to the amino group, but the fluoro group will break the tie. So you want to give lower number to this fluoro because for this amino group is always 3 anyway. So the name will be 1 fluoropentane. This is the pentane is the parent, okay, and then 3 is the location of amino group and 3 amine. For this one, we pick up the longest carbon chain. The other R group will be just substitution. Okay, number 1, 2, 3. You want to give this amino group lowest number. Okay, so the name will be N2-dimethyl. 1 methyl is on nitrogen, 1 methyl is on carbon 2 of the parents. So you have this N, 2, and then dimethyl. So the little hyphen is separate the letter and the numbers. Okay, same thing here. See, number and the letter, you use a hyphen to separate them. Okay, comma separate the location or the number of the same substituents. N and comma 2 and hyphen dimethyl propane is the prefix of the parent, and then 1 is the location of this amino group, 1 amine. Okay, For this tertiary amine, we pick up the longest one. Is 1, 2, 3, 4, right? So 1, 2, 3, 4. That's a but. And then we have a methyl and an ethyl and a chloro as 3 substituents. And alphabetic order, you have to say chloro first. 1 chloro, N ethyl, and N methyl, butane, and 1 amine. Butane is the prefix or parents. This 1 is the location of this amino group. Okay. Now let's talk about the alcohol. The alcohol have functional group hydroxyl group here. This is a primary alcohol because it connected with the primary carbon. That's a secondary alcohol, that's a secondary carbon. That's a tertiary alcohol, that's a tertiary carbon here. Okay. So for this one, you need to pick up the longest carbon chain. Apparently is here, 1, 2, 3, 4, and number 1 because you want to give highest priority, lowest number. That's a priority highest. That's here. It's higher than amino group, higher than double bond, triple bond, higher than alkyl, halo, and alkoxy. 1, 2, 3, 4. So this methyl group is at carbon 2. So that's 2-methyl butane 1O. And this 2 is the location of methyl group. This 1 is the location of this hydroxyl group. For this one, we have a tie because we actually don't have time because hydroxyl group is higher priority than amino group. So this carbon must be 1, 2, 3, 4. So this will be 3 amino butane 2O. See, amino group is this group because now this amino group is not the highest priority. So you have to use the prefix name amino. Okay, so that's a 3 amino butane 2O. 2 is location of this hydroxyl group. That's carbon 2. And then last example, longest carbon chain. 1, 2, 3, 4, 5, 6. We want to number this one because we want to give a low number to this hydroxyl group. If you number that as 1, that will be 4. Okay. Name 3-methyl, methyl on carbon 3. 3-methyl hexane. Hex is the prefix of the longest parents. Okay. And then 3O. 3 is location of the hydroxyl group. 3O. OL is the suffix of this alcohol because in this 3 example, the hydroxyl group is the highest priority. Let's look at the ketones. Ketone will have a carbonyl, okay, and connect with 2 other carbons. This is the simplest ketone, okay. It's called propane 2O. Prop is the prefix of the parents, 3 carbons. 2 is the location of this carbonyl. So propane 2O. Common name is acetone. Okay, that's a very common organic solvent. Now this is more complicated ketone, so we need a number 1, 2, 3, 4, 5, 6. Again, we want a low number of the carbonyl here, the ketone, higher priority than alcohol even. So, and the methyl is carbon 5, so that's a 5-methyl hexane 3O. 3 is the location of this ketone. Now, like I just said, ketone has a higher priority than alcohol. So we need to number this 1 to give the low number to the ketone. 1, 2, 3, 4, 5. And then that hydroxyl group is on carbon 4. So that's a 4-hydroxy. How do you know hydroxy? Because now we treat this as a substituent. For alcohol, we call the hydroxy prefix when they are not the highest priority hydroxy group. 4-hydroxy, pentane. Pentane is a prefix, and 2 is the location of the ketone, 2O. O-N-E is the suffix if the ketone is highest priority. Next, aldehyde. Aldehyde, this is the simplest aldehyde, just 1 carbon. We call this methanol. Al is the suffix of aldehyde. And the common name, formaldehyde. Okay. And now, if you have a ketone and aldehyde together, aldehyde is a higher priority than ketone, so we treat this as a substitution, the ketone. So we call this oxo group. Number, this carbon of aldehyde is carbon 1, 2, 3, 4. So this will be 3-oxobutanol. Okay, it's aldehyde. This example, we have amino group here. Again, amino group is not higher than aldehyde. So we treated this as a substitution. That's amino group. So we have another methyl group here. So carbon 1, 2, 3, 4, 5. And then this will be 2 amino, 3 methyl, see alphabetical order, and then pentanal. Pent is the prefix of the parent, and then al is the suffix. Let's look at the carboxylic acid. This is the simplest, not the simplest, but the maybe most common carboxylic acid. That is ethanoic acid. Ethanoic acid, 2 carbon, eth. Okay. Oic acid is a suffix. Common name is acetic acid, which is the acid in vinegar. If we have aldehyde here and carboxylic acid still highest priority, so we treat this aldehyde as substituents. Carbon 1 is here, 2, 3, 4. Then this will be 4-oxo-butanoic acid. Last example, we have again longest chain is the 4 carbons, and we have hydroxyl group here that's also lower than carboxylic acid, endo-chloro. So number 1, 2, 3, 4, and that will be 3-chloro, 2-hydroxy-butanoic acid. Okay. So I didn't give you all function group here. I just give you some common examples, and I hope that can help you understand how to name the organic compound. For this mini lecture is for this acyclic compound. Okay, so for cyclic, for aromatic, for alkenes, I will talk about in other mini lectures. Okay, if you have any question, please let me know. Good luck.